Weight, mass, normal force, and equilibrium. Weight versus mass. Mass is the amount of matter in an object. It's measured in kilograms. Mass is a scalar, and your mass is the same everywhere in the universe. Weight is force due to gravity. It's measured in newtons. Weight is a vector. It always points down, and your weight can change if you go to space or to another planet. The equation for weight is Fg equals mg, where g is acceleration due to gravity, is 9.8 meters per second squared on Earth. Okay, so using this equation we can switch between mass and weight. Normal force is a contact force exerted by a surface perpendicular to that surface. For an object resting on a surface, the normal force will be equal and opposite to the gravitational force. So to get the normal force, it's going to be normal force equals Fg equals mg. Here are some exceptions. Free fall. When you're in free fall, there's no surface to hold you up, so there's no normal force. On an incline, you'll slide down the incline, so the normal force and gravity will not cancel out. And on an elevator, you can accelerate up or down, so the normal force and gravity may not cancel out. Equilibrium occurs when all forces on an object cancel out. When you're in equilibrium, the net force on an object is equal to 0, and the acceleration is equal to 0. Alright, there are two types of equilibrium. Static equilibrium is when you're at rest, and dynamic equilibrium is when you're at constant velocity. A sample problem: a 23 kilogram mass rests on a table. What's the normal force acting on the mass? Okay, rest, so we know we're in equilibrium. The net force is equal to 0 and all forces cancel out. Force of gravity we can calculate. Fg equals mg, and we get 225.4 newtons. And since I know that all forces cancel out, the normal force is equal and opposite to the force of gravity, so it's 225.4 newtons.